Ma-access nimo yung values kanang by
Okay,
indexing.
correct. Very good. So you can access each elements in your array components. Okay, so here is your reward for participating, Leo. Okay, very good. All right. Okay, so now let's proceed to our discussion. We will just put this one here. Okay, we'll just tie this one. And we will just revisit um, these learning outcomes afterwards. Okay, we'll just put it here. And all right. So again, this morning we will tackle arrays and some of its operations. But first, what is an array? So it is a data structure which consists of a fixed number of components. So that is one of the disadvantage of array is having the fixed number of components. And with each component of the same type. If you have the type of integer, so all of the elements of that array must be of integer. And if you have an array of objects, all of the elements must be objects. And its primary characteristics include name, the component type, and the indices of the first and last elements. Okay, same as with this example, we have an array of scores with 5 components. Okay, and all of the elements must be of type integers. So this will cater integer values of these array scores. All right, so we have the first component start at index 0 and the last component must be the size minus 1. So at index 4. Okay, and you can put values from index 0 up to 4. Okay, now we have several operations of array and it requires traversal. Okay, traversal is accessing or visiting each element of the array. And the most common way of accessing or visiting each element of the array is by the use of looping. Okay, and the common loop that we are using is the for loop. Okay, since we feel so comfortable. Okay, for loop is very convenient in using the array in traversing the components. And each execution of the loop processes one element in the list, just like populating the content or printing the content or visiting the element or doing such comparison. Okay, something like that. And the loop terminates when all elements have been processed. And example of the operation is the printing, okay, which requires traversal. So printing the array elements. And others are populating, finding minimum, searching. And for searching is to find the location of a target among a list of objects. Okay, so we have here. All right. So searching, there are two basic algorithms for searching an element in an array. And these are the sequential search and the binary search. For the sequential search, this will be used whenever the list is not ordered since we are going to search the target item starting from the first element up to the last element. Okay, or until the target has been found. And for the binary search, this will be used whenever the list is ordered. Okay, because we have something to do with eliminating a particular part of the array elements, okay? Because we need to divide the list into two, and from the word binary, so there's something from the word by, so it means two, okay? So we have something to do with the list. All right. Oh, we need to proceed to the next slide. And for that one, I cannot locate for, sorry. Where is that edby file? And it's not found here. Anyways, okay, let me just use this sharing tools. Okay, I know not this desktop sharing na lang. Since we are, there are 13 students here, so I can use my teacher sharing tools. Okay, teacher screen share. All right. So again, so for the searching operation, there are two basic searching algorithms, the sequential search and the binary search. Sequential, from the word sequential, we have to search the elements sequentially, starting from the beginning of the list up to the end. All right, let me just, okay. And for the sequential search, start searching for the target at the beginning of the list and continue to find the target. And we have to examine or compare each element until we reach the end of the list. And there is a time complexity of O of n. Why O of n? Because it depends on the size of the array. Okay? And we have here the algorithm for using the sequential search. So we have the looker, which is initialized to 1, and we have to use loop, okay, to start looking the target, starting from the beginning of the list. And we have to update the looker, okay, to jump to the next element if not yet found, okay? If the target is equal to the element at the specific index, and in this case, we have used the looker variable, so return the Boolean value true, else return false. Okay? Then, after the target has been found or after you reach the end of the list, you return the value of either true or false. Okay? And it is illustrated in this figure. Wait, let me have some here. From Jade Sidalio, Miss, dugay kasud si Pontilias kay ga-update pas iyang class in. Okay, this is noted. Thank you. Okay, don't you worry, the discussion is being recorded. Okay, now using the sequential search, and the target item is 14. And we have our list of 4, 21, 36, 14, 62, 91, and 8. And we have 7 items here. Okay, and the indices used are from index 0 up to index 6. Now, okay, so we have to compare the target item, which is 14, to the element at index 0. Okay, is it equal to? No, not equal to. So proceed to the next element. Okay, so this is our second comparison to compare the target 14 to the element at the element at index 1. So is it equal? No. So proceed to the next element. Okay, so for the next element, to compare the target item 14 to the element at index 2. Is it equal? No. So proceed to the next. So compare the target item 14 to the element at index 3. Is it equal? Yes. So return found. So the item 14 is found at index 3. Okay? So how many comparisons will it take to locate the target item 14 in this list? So in this case, there are 1, 2, 3, 4. So there are 4 comparisons to look for number or to look for the item 14 in this list using the sequential search. All right. Okay. Now, for example, if you are going to look for the target item 100, how many comparisons will it take to look for the target item 100 in this list? Any other idea? Okay, you can raise your hand if you want to share your answer, or you can use the chat box if you don't have the microphone. Again, how many number of comparisons will it take to locate the target item 100 in this list? Uh-huh. Can I have uh-huh is here on the stage. Okay. Shall we have Maiso? Hi Maiso. Can you hear me? Can you raise your hand, Maiso, so you'll be put on stage? Yes. Okay. Maiso. Yes. You're audible. Okay, again, how many comparisons will it take to look for the target 100 in this list?
I have no idea.
Okay, and we have a hand of Rex. Yes, Rex.
It takes 4, Miss.
Okay, so let's try to see. For the target item 100, okay, using the sequential search, we have to start searching the target item at the beginning of the list. Okay, so the first comparison is to compare 100 to the first element. Is it equal? No. So proceed to the next. Is it equal? No. So proceed to the next. Is it equal? No. So proceed to the next. Is it equal? No. Proceed to the next. Is it equal? No. So proceed to the next. Is it equal? No. And is it equal? No, but we have reached the end of the list. Therefore, how many comparisons? Kapila man ta nag-compare? 1, 2, 3, 4, 5, 6, 7. So this is the worst case scenario if ever the target item is not found in the list. So we are having 7 comparisons to look for the target 100. Okay? All right. So other question. Okay, so we have here from sorry Miss okay, that's one. Okay. All right. So Next target item is 62. Okay. How many comparisons will it take to look for the target item 62? Yes, John Ray. Okay, so we
5,
have
Miss.
responses from John Robert, Cedilio, Nicole, Yuri, 5. All right, so let's try to check.
5.
Okay, so 62 start comparing from the first item. So compare to 4, no, compare, no, compare, no, compare, no, compare, yes. So the target item is found at index 4. So therefore, how many number of comparisons? 1, 2, 3, 4, and 5. So there are 5 comparisons in looking for 62 using the sequential search. Okay, the last item to be searched is, okay, 65. Okay, how many number of comparisons will it take to look for number 65 in the list using the sequential search? Okay, yes, Yuri. Yes, Yuri. Okay, so we have responses here, 7. So let's try to check. Okay, so start comparing here. No, 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 and no. So therefore, there are 7 comparisons in looking for the target 65, and it is not found in the list. Okay, so I think you already got the idea of the sequential search. Okay, okay, so the best case scenario of using the sequential search if the target item is found at the beginning of the list. All right, so let's proceed. Oops. Shall we have? Okay, so now using the binary search. Oh, wait, can I remove these things here? Okay. All right. So in binary search, you have to start by testing the data and the element at the middle of the array. Okay. Wait. All right. So to find the middle of the list, we have the formula. Mid is equal to first plus last divided by 2. Okay. If it is in the first half of the list, we do not need to check the second half anymore. But we have to eliminate the half of the list. Okay, and repeat this process until we find the target or satisfy ourselves that it is not in the list. So there is faster time complexity in using the binary search if ever the list is sorted. Okay, again, we make sure that the element in the list must be sorted first before using the binary search. All right. Now, please remember the formula of getting the middle element of the list in a binary search. Mid is equal to first plus last divided by 2. Okay. Now, still the target is 14. And the list is, we have 10 items here. Okay, and try to verify the list is already sorted. Okay, it's already arranged in ascending order. Now, using the binary search, we have to use the formula. Okay, Mid is equal to first plus last divided by 2. Okay, so first is the first, the index of the first element, and the last is the index of the last element. And in this case, of course, first is 0 because the first element is stored at index 0, and the last element is the size minus 1, which is 9. Okay, now, so ganito, mid is equal to first plus last divided by 2. Okay, mid is equals to first plus last divided by 2. Can I have this one? Okay. Okay, mid is equal to first plus last divided by 2. Okay. And the first is 0 and plus last, which is 9, divided by 2. Okay, wait, we need to put a parenthesis here. Okay, so that after getting the sum of first plus last, the result will be divided by 2, and that is the middle. So 9 divided by 2 is 4. Okay, so 4. So not 3, but 4. All right. I'm sorry. There is a typo error here. Okay, so we have to compare our target item to the element at the middle. So is 14 less than the element at the middle? Yes, it's less than. Therefore, we need to eliminate this one. Okay, and remember, the target item is not at the middle. All right, now what will happen to the last will be mid minus 1. Okay, if ever the target item is less than the item at the middle, our last is equal to, okay, mid, okay, mid minus 1. Okay, and in this case, our mid is will become 3. All right, and still our first is 0. Okay, now get the middle of this list and still apply the formula. First plus last divided by 2. Last is 3. Okay, so 3 divided by 2 is 1. Okay. All right. So 3 divided by 2 is 1. Now, compare the element, the target item, to the element at index 1. So the element at index 1 is 6. Okay. So 6. It's not equal to the element at index 1, but it's greater than. So we need to eliminate this one and let the first will be this one. Okay, so if ever the target item is greater than the element at the middle, let first is equal to mid plus 1. Okay, first is equal to mid plus 1. All right. So when your first will be mid plus 1, it will become, okay, mid plus 1, it will become 2. All right. So your first will become 2 since your previous mid is 1. So increment by 1 or add by 1, then it will become 2. So this is your first now. All right. Then get the middle of 2 and 3. Okay, so 2 plus 3 divided by 2. And that is your middle. So 5 divided by 2 is 2. All right. So compare the target item to the element at index 2. All right. So is it equal? No, but it's less than. So the element at index 2 is less than the target items. Therefore, the first will be altered to mid plus 1. So first will be 3. Okay, and still last is 3. Okay, and divided by 2. Okay, so 6 divided by 2 is 3. Now, compare the target item to the element at index 3. Okay, so, okay, now this is not 2, but your first now is at 3, and last is 3. Of course, your mid is 3. Okay, so compare. Yeah, the target item is found at the middle, which is at index 3. So return the location of the target item, which is index 3. Okay, and terminate the function. All right. So how many comparisons will it take to look for the target item 14 using the binary search? So first comparison is here 1, next 2, next 3, and next is 4. So there are 4 comparisons. Okay, to look for the target item 14 using the binary search. Now, for example, if you have to look for the target item, okay, 31. Okay, how many comparisons will it take to look for the target 31? Can you guess how much? Okay, so using the mata-mata, for example, did you already get the idea of using the binary search? So Nicole Trasmonte said 8. There are 8 comparisons. Rex also said 8. Now let's try to check. Okay. The first one, all right. To look for the target item 31 using the binary search, of course, we have to locate the middle element and compare. So first, 0 plus last is 9. 0 plus 9 divided by 2 is 4. So this is our first comparison. Next comparison, okay, can I use the blue one? Okay. So first comparison is at index 4. So 31 is not equal to 18, but it's greater than. So this will be our first. Okay. First, and still our last is 9. Okay, 5 plus 9. Okay, divided by 2. Okay, so 5 plus 9 is 14 divided by 2. So our mid is at 7. Therefore, there are only 2 comparisons to look for 31 using the binary search. Okay. All right. Maybe you are using the sequential search. Again, there are eliminations happened in the binary search. There are some list or items that will be eliminated using the binary search. Okay. That is why there are only 2 comparisons in looking for the target 31 using the binary search in this list. All right? Okay? Did you get the idea on why we only have 2 comparisons in looking for the target item 31? The first comparison happened at index 4 since the middle is 0 plus 9 divided by 2 is 4. Okay? And the element at index 4 is not the element that we are looking for. Therefore, but it's greater than. I mean, the target item is greater than the element at the middle. So let the mid plus 1 be our first. That is why I put F here. Okay? And in this list, get the middle. So 5 plus 9 is 14 divided by 2 is 7. So this is our middle. Then we have to compare. And it happened that the target item 31 is found at this middle. Okay, at index 7. So return found is equal to true. So there are only 2 comparisons. Okay. Now, let's try to look for another item. Okay. Can I erase some? Oops. Okay. Can I have? Oh. Mhm. All right. So let's clear this one first. Okay. Again, there are 2 comparisons. Now, okay, let's try to look for the target item 6. All right. How many number of comparisons will it take to look for the target item 6 using the binary search? Again, binary search. Okay, I will give you time to just okay, solve it on your paper there or any tool you like on your device. Okay. Okay, please remember the concept of getting the binary search or getting the formula of the middle in the binary search. Okay, so we have responses from Nicole, Leo, and Vargas. So we have 2. Okay, they said there are 2 number of comparisons to look for number 6. Okay, now let's try to verify. Okay, so the first comparison happened at what index? So the middle of 0 and 9 is 4. So this is the first comparison. So the target item is not found, but it's less than. Okay, so this will be your last and this will be eliminated. Okay, this will be your last and still your first is 0. Now second comparison will be at 0 plus 3 is 3 divided by 2 is 1. So the second comparison is happened at index 1 and it returned true since the target item is found at index 1. So therefore, very good. So there are 2 comparisons, okay, to look for number 6 using the binary search. Okay, so I think you already got the idea of using the binary search. All right, so last one. Okay, so last one. Can we have, okay, so there are two. Can we have 100? Okay, how many comparisons will it take to look for number 100? Okay, to look for number 100, how many comparisons? Okay, you have to control on your loop that your first must not be greater than your last. Dapat dili na magsungkahi. Otherwise, the function will be terminated. Okay. Uh-huh. Okay. Now, okay, so let's try to look for number 100. Okay, the first comparison, okay, will happen at the middle at index 4. So it's not equal, but it's greater than. Okay, so therefore, this will be your first. Okay, mid plus 1. And this will be eliminated. And in this list, get the middle. 5 plus 9 equals 14 divided by 2 is 7. So this is your middle. And this is your second comparison. Is it equal? No, but it's greater than. So eliminate this one. And this will be your first. 8 plus 9 equals 17. Divided by 2 is 8. So this will be your middle. It's not equal, but it's greater than. So let this one be your first. And at the same time, your last. 9 plus 9 divided by 2 is 9. Therefore, you have to compare this one. The target item is not equal to the element at index 9, but it's greater than. And let your F be mid plus 1. Now your F is 10. Okay? And it's now greater than the value of your last. Therefore, your function of binary search will be ended. Okay? Or will be terminated. And the target item 100 is not found in the list, and there are 4 comparisons in looking for the target number 100 in this list. Okay? All right. So now let's proceed. Okay. Can I erase some things here? All right. All right. Okay. So other operation is the insertion. And you have many options to insert an element in the list. You have the option to insert at the beginning, you have at the middle, and you have at the end. So in inserting an item at the beginning of the list, you have to move the elements. And where are you going to start moving? From the next adjacent cell or from the last component? Any other idea? Okay, any idea on where are you going to start moving? Okay, since you are going to insert the beginning, and this will be moved to the next adjacent cells. Okay, after moving, you can let the new item be the value of the item at the first, or array sub 0 is equal to the item to be inserted. All right? Okay, so let me have, I don't have the tool here. Okay, how many of you say you are going to start moving at the end? Okay, kindly raise your hand. So we have Lord Leo. How about the others? Okay, you start moving at the end of the list. Only Leo will say, and how about the others? How about start moving right after the first element and to the last element? Okay, so I think all of you will say that you are going to start moving from here. So let's try. Now, if you are going to start moving the element at 2 to the next adjacent cell, what will happen? 2 will be copied here. So this will be overwritten with 2. And this one will be copied here. This will be overwritten by 2. And this will be overwritten by 2. So the number, the the value of the first element will be copied to the next adjacent cell. And you are not moving. Okay? So, Leo is correct that we have to start moving at the last element. Okay? That is you have to start moving starting from 9. Okay? So, starting from 9, you will copy it here. So, 9 will be put here. Then, let your array sub I minus 1 be array sub I. Okay? So, let 3 will be overwrite here. And let 6 will be overwrite here. And 1 will be overwrite here. And 2 will be overwrite here. And let the first element be overwritten with the new item 5. So, you are moving the elements 2, 1, 6, 3, 9 to the next adjacent cells. All right? Okay, very good, Leo. Can you raise your hand, Leo? Okay. All right. So for Leo, can I have some points for you? Leo Lagari. Oh my goodness. Oops, where are you? Okay, and here is your reward. Okay, now let's proceed. For inserting the element at the middle of the list, of course, you are still going to move. Okay, and again, where are you going to start moving? For example, we have the middle of the list is at index 2. Okay, since we have 5 elements here. Okay, so we have to insert the item 5 here. And what will happen to 6, 3, and 9 will be moved to the next adjacent cells. So again, same as with inserting at the beginning of the list, you have to start moving the item starting at the end. So let 9 will be put here. Okay. And 3 will be moved here. And 6 will be copied here. Okay. Actually, we are not just moving. We are not moving, but we are just copying the items. And this will be the location that you are going to insert the new item. So this will be overwritten with 5. Okay. Now, if you are going to insert the item at the end of the list, are there any moving of elements? Wala. Okay. So you can just put the new element to the end or to the last element of the list. Okay. Or next to the last element of the list. That is from size of 5. And of course, you have to increase the size by 1. Okay. From 5, increase by 1. So your size will be now 6. Okay. And that makes 216395 as your elements. All right. Now, the other operation is, okay, so this will be your item insertion algorithm. All right. So we'll just get back on that. Now, for the deletion. So it requires that the list be searched to locate the data to be deleted. Yes, we have to locate the position of the item to be deleted. Okay. And once located, the data are removed from the list. And when the data are deleted from the array, the data following the deleted item must be shifted to replace the empty element. Actually, you're not going to delete actually, but you can just overwrite, okay, to remove the item from the list. Okay, overwrite the item from the next adjacent cell to the item to be shifted and then or to be removed. Then where are you going to start moving? Is it from the last or right after the location of the target item? Okay, so this is just the opposite of inserting at the middle or at the beginning, that you are going to start moving right after the cell or the location of the target item. Okay, that is, since we are going to remove 6 from the list, so the next item, which is my array sub I plus 1, will be moved to my array sub I. Okay, so that is 3 will be moved to here. Okay, 3 will be moved to here, so this will be overwritten with 3. And this will be overwritten with 9. Okay, and this one will be overwritten with 5. And this one will be overwritten with 4. Okay, and size minus minus. Okay, that will drop this element. Okay, all right. All right, so right, very good, Vargas. Okay, so you have the point. Okay, right, later I will give you the rewards. All right, so now let's proceed. Okay, let me just remove these writings here. Okay, all right. Now, so this is the item deletion algorithm, and we will talk that one on the later session. All right, so what time is it? It's already 8:58. And Okay, there are only 2 minutes left. Any questions? Okay. Now you can raise your questions about the concept of array and array operations. Before we'll have the checkup quiz. Remember the number of comparisons for the sequential and binary search, because those algorithms are highlighted in this discussion, and that will be part of the checkup quiz. Okay, so let's have a short demo for some of the operations. Okay, so I think there are no questions. We will be using the Atom editor. Okay, and we have the two processor directives here, the stdio.h and the conio.h. All right, and we have to create the main method, and its type is integer, therefore we need to return an integer value. And to freeze the results on the screen, we have to have the getch function. And since we need to have the array, so we need to declare an array object, and let's try to call that my array. Okay, of size. Okay, let's try to define the size of array. Okay, like max, and that is 10. And this will be our size. Next, let's try to populate. And as I've said, okay, let's try to make it that the user will enter the values for our array elements. Okay, so we will be using the user-defined methods. So different methods or functions for the array operations. And we will call this one populate. Okay, populate. And for this populate function, we'll receive the array of type integer, and we'll name this one as, okay, you can use any name for your array, okay, but in my case, I will just be using the same name, my array, and the size. So we are going to pass the array and the size as arguments, and this will receive the values of size and the array, okay, as formal parameters, and that will be processed inside this function. And here, okay, in the function call, we are going to pass the name of our array and the size, which is max. And since we need to have to declare the function, we need to put it here. Okay, just a function heading for our declaration statement. Okay, and here, first we have to instruct the user to enter. Please enter like 10 integers. Okay. Okay, 10 integers. And 4. Okay, we need to use loop to populate each elements of our array of 10. Okay. Start at 0, I is less than the size. So this will repeatedly asking the user to enter an integer until it will reach the size of 10. Okay, until the user will enter 10 integers. Then I plus plus. Okay, then okay, we have to assign, the integer value, assign it to the my array sub I. So we are using the subscripting operator, the rectangular bracket. Okay, for the first element, then second element up to the last element. Okay, then let me just alter it one and put it here, specify. Okay, even though this is a not a compound statement. All right, now let's try to print, okay, to verify if the item is successfully populated. Okay, print like in a horizontal format. Those integers will be separated by a space, and here we have to pass the name of the array and the size. Okay, then here, okay, we will just have the void type. Okay, and same with the populate. This will receive the array. So we have our array here and the size. Then, okay, array elements are, since we will be accessing the elements of our array, we need to use loop for that. Okay, for I is equal to 0 and I is less than the size of the array and the I plus plus. Okay, then those elements will be printed in a horizontal format using a space, okay, and %d. And how are you going to access each element? So using the name of the array and the subscripting operator, my array sub I. Okay, save. All right, don't forget to put the declaration statement here. Then colon, a semicolon. Save, and let's try to run this program. F5. Okay, so please enter 10 integers, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oops, sorry. Wait. Not yet printed. Okay, let me just put this one and here. My array sub I. Sorry, that is why. We need to have the ampersand here just to set the value being entered by the user to each of the elements started at index 0. Okay, save and press F5. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so here are the elements. Okay, nasobra tag enter ko sa 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have the 10 elements. All right, so we have successfully assigned each element and printed the element. Okay, any questions so far? Yes, Leo?
Miss ka na sa para sa populate nga function is ba?
Mm-mm.
Kaning parameter nga may array miss ba kay mao rin siya miss kana sa scanf miss dili na di ka maghimo variable bag-o miss nga may
Now,
array.
if what you are using here, this will be used inside your function. So, for example,
Oo, miss kay
my
lahi
array
man gid.
sub1, if you are using the my array sub1 as the name of your array in your formal parameter, so my array sub1 also must be used in your function. This is different from here. Okay, this will just receive the copy of your array being passed as an argument
Yes,
here
thank
in
you
your
miss.
call. Yes. Okay, any other questions? Okay, any other questions? None? All right. So, yes, Yuri.
Saan pag-apply sa deletion aramis?
For the deletion, okay. For the deletion, since the algorithm is already posted, okay. For the deletion, you are just going to locate the target item to be deleted and get its position. Okay. Say, for example, the target item is where is it? Oh, so we have a notification from the class in app that our class is over now and the classroom will be closed in 20 minutes. Okay, so just go back to here. All right. Okay, so for example, you are going to delete 6. What is the location of 6? So it is at index 2. So starting from index 3, you will be moved at index 2. So what will be the content of your code? Where is my now? I don't have the text na. Can I enter any number? Ni-exit na ako ang usa. Okay, wait for a while ha. Nawalang ako ang tool. All right. Okay, sige. Sige, I will just give you the hint na lang. Okay? Okay, since this is already asked by Yuri and supposedly this will be our next item or next activity. Okay. I will just give you. Okay. And since we are just catching up the time, oops. Can I have the, all right. Okay. So I have already the pre-created code for deleting an item. So first, we have to get the position of the target item to be deleted. Remember that we need to have the item to be deleted. So there are 3 parameters. The first one is the array and the size, and the last one is the target item to be deleted. And we have the variable position to get the location of the target item. And to look for the target item, we have to search, okay, from the beginning of the list. Just like we're going to search the item using the sequential search. Then, using the loop, okay, to step from the first element up to the next element or until the item has been found at a specific position. That is why we are comparing the target item to the element of the list starting from I. Okay? My array sub I at index 0. If the target item is equal to the item at index I, so get the position using the I value be assigned to the variable position. Okay? Meaning if the item is not found, the position value is negative 1. Okay? If it is negative 1, so the target item is not found in the list. Okay? And once found, okay, just overwriting with the value 0 and having another loop to shift the item, okay, right after the next adjacent cell. That is, okay, that is here, okay. Let the j is equal to the value of I, okay, so which is the position of the target item. For example, 3, okay, for example 3. Or in our example in the slides, we have the position at index 2. Okay, so let my array sub I be the value of my array sub j plus 1. Okay, so at index 2, overwrite with the value at index 3. Nakuha? Did you get this statement? Okay. My array sub j is equal to my array sub j plus 1. So whatever the value of the my array sub j plus 1 will be shifted to my array sub j. So in this case, my array sub j is 2 and my array sub j plus 1, meaning the value of the element at index 3 will be assigned to 2. And that is why we are having this 1. Oops. Okay. All right. That is why I said that we have to start moving right after the location of the target item. Okay. So zero, 1, 2. Our target item is found at index 2. Okay. And let my array sub j plus 1, which is the value at index 3 plus 1, will be assigned to 2. So let this will be overwritten with 3. Okay. Oops. Next, this will be increased j plus plus. Remember, until we reach the size j plus plus, this will become 4. Okay, and this will become 4. The value at index 4 will be overwritten with the index 3. So this will become 9. And this will become 5. And this will become 4. Right? And size minus minus. So we have 2, 1, 3, 9, 5, 4. Okay? All right, so it's already, we already delayed in 18 minutes. Okay, so as part of your assignment, so we have a chat from here. Okay, miss, thank you. Okay, thank you, Yuri. All right. So as part of your assignment, it will be a team assignment. So you are asked to choose a partner, okay, to perform the following array operations. And this must be the output. Okay. Oops, wait for a while. Okay. So it must be a menu-driven program for populating, searching, delete, find minimum, find maximum, display, and insert. Okay. For searching, you can just use you have the option to use the sequential search or binary search. It's up to you. So for example, I'm going to populate, but in this program, I have just used the random numbers from 0 up to 100 inclusive for the um, populating the array components. Okay. And since I have already populated, let me just display 6. But in your case, you can just use the way that I have coded for populating. Okay, so these are the elements of my array. Okay, now let's try to use search. Since I'm using the random items from 0 up to 100, the elements are not yet sorted. That is why I am using the sequential search. Okay, let me just try to search. Input number to be searched, like for example 50. Search item is not found. Now let's try to display again and look for the item to be searched. Let us say 44. Search for 44. Okay, so 44 is in position number 3. Okay, find minimum, find maximum. Okay, delete. For example, I'm going to delete 3 and 44. 44